On the 17th of January, 1803, in a room inside Newgate Prison in London, a crowd of scientists, doctors, and professors gathered around a table. On the table was the body of a man named George Forster. He had been executed by hanging 1 hour earlier for the murder of his wife and child. What happened next in that room was witnessed by everyone present. Several of them went home and could not sleep. At least one account says a woman who heard the description of the event fainted. And one newspaper the following morning declared that what had occurred was, without question, proof that the boundary between life and death was not a wall. It was a door. The man performing the experiment was an Italian scientist named Giovanni Aldini. He was 36 years old. He was the nephew of the man who had discovered that electricity could make a dead frog's leg jump. And he had spent the previous decade pushing that discovery into territory that almost no one else was willing to go. He was not trying to raise the dead. That is the myth. What he was actually trying to do was, in some ways, even more disturbing. He was trying to understand where the line between living and dead actually was. He believed that electricity, the newest, least understood, most terrifying force that science had encountered, was the tool that would show him. 15 years after Aldini's Newgate experiment, a 19-year-old woman named Mary Shelley sat down and began writing a novel. She called it Frankenstein. She had heard about Giovanni Aldini. This is the real story. Giovanni Aldini was born in Bologna in 1762, the son of a noble family and the nephew of Luigi Galvani. He studied physics and natural philosophy at the University of Bologna and graduated with a doctorate in 1782. He was brilliant, ambitious, and possessed of a showman's instinct for spectacle that his careful, methodical uncle entirely lacked. When Galvani published his work on animal electricity, Aldini was immediately fascinated. But he was also watching a controversy unfold. Alessandro Volta was arguing that Galvani had it wrong. The electricity was not coming from the animal at all. It was being generated by the contact between two different metals. Whatever the source of the electricity, the muscular response in dead tissue was real. And Aldini wanted to know how far that response could go. He began experimenting with larger and larger subjects. Ox heads purchased from slaughterhouses. Then whole animal carcasses. He was systematic. He was meticulous. He began touring Europe with his experiments, performing public demonstrations before scientific societies in Italy, Germany, and France. These were not fringe events. They were attended by some of the most respected scientists and philosophers of the age. And they were reported in major newspapers and scientific journals. He was a serious researcher who understood that the visual drama of his experiments was also their scientific substance. The body moving was the data. But in London, in January 1803, he was about to perform a demonstration that would go beyond anything he had done before. Because in London, the subjects available to him were not ox heads from a slaughterhouse. The Murder Act of 1752 in Britain had established that the bodies of executed murderers could be handed over to surgeons and anatomists. It gave anatomists legal access to fresh human bodies. They were human. This was the most powerful electrical device then available. And Aldini intended to use it at its full capacity. He had come a very long way to stand in that prison room. And he was not finished yet. The Newgate experiment was not a private affair. It was reported. It was discussed. It rippled outward through the scientific and literary communities of Europe. In 1814, a poet named Percy Bysshe Shelley attended a demonstration of galvanism and came home electrified, in both senses of the word. He talked about it with his companions for days. 2 years later, in the summer of 1816, Percy Shelley was staying at the Villa Diodati near Lake Geneva with his partner Mary Godwin, the poet Lord Byron, and Byron's physician John Polidori. That summer in Switzerland was extraordinarily cold and dark, the result of a volcanic eruption in Indonesia the previous year that had thrown enough ash into the atmosphere to alter the climate of the entire northern hemisphere. Crops failed. Skies were gray for months. It became known as the year without a summer. Confined indoors, the group began telling each other horror stories. Byron proposed a contest, each of them would write a ghost story. Mary Godwin, who was 18 years old and would later become Mary Shelley, could not think of one. For days, nothing came, and then one night she had a vision. She described it later. She saw a pale student of unhallowed arts kneeling beside the thing he had put together. She saw the hideous phantasm of a man stretched out, and then, on the working of some powerful engine, it shows signs of life. She said the vision came partly from the conversations about galvanism that had been circulating in their group. The idea that electricity could animate dead matter, that a scientist might, in some future moment of terrible knowledge, be able to restart the machinery of life, was in the intellectual air of that summer. She wrote it down. She expanded it into a novel. And in 1818, Frankenstein, or the modern Prometheus, was published. It is considered the first science fiction novel. It is certainly one of the most influential books ever written. Victor Frankenstein's crime is not that he is evil. His crime is that he is curious. That he pushes past the boundary that society and nature have placed around certain kinds of knowledge. That he succeeds where no one was supposed to succeed. He is Giovanni Aldini, taken to the logical extreme that Aldini himself never reached and never claimed to reach. The monster in Frankenstein is not just a creation of fiction. It is the cultural fear of science without ethics. Of knowledge without wisdom. Of a world in which the definition of life and death is no longer theological, no longer God's territory, but experimental. Negotiable. Subject to revision by whoever has the biggest battery. Aldini spent his later career pursuing the practical applications of his work. He developed early proposals for safety equipment in mining, for electrical treatment of mental illness, for the medical use of galvanism in paralysis. He received honors from the French Academy of Sciences and was knighted by the Austrian Emperor. He died in Milan in 1834, a respected and decorated scientist. He never quite understood why the world remembered him not as a medical pioneer, but as the man who had made a dead face grimace in a London prison. To understand what Giovanni Aldini was doing in that prison in 1803, you have to go back to a kitchen in Bologna in the 1780s. Luigi Galvani was a professor of anatomy at the University of Bologna. He was a careful, methodical man who was not looking to change the world. He was simply trying to understand the nervous system. The story goes that one afternoon, a dissected frog was lying on his workbench near an electrostatic machine. When a scalpel touched the frog's exposed sciatic nerve at the same moment that the machine discharged a spark nearby, the frog's leg kicked. Not a twitch. A kick. A full muscular contraction, as if the frog had decided, for one fraction of a second, to jump. Galvani was transfixed. He spent the next decade studying the phenomenon. He hung dead frogs from iron hooks on his balcony during thunderstorms and watched their legs move when lightning was in the air. He connected different metals to different parts of the frog's anatomy and found that certain combinations produced movement without any external spark at all. He concluded that what he was observing was something he called animal electricity. He published his findings in 1791, and the scientific world erupted. Because what Galvani had apparently shown was this, that the electrical force which moves a living muscle is not destroyed at the moment of death. It lingers. It remains. And it can be awakened. The philosophical implications were staggering. If life could be electrically simulated in a dead body, even momentarily, then what exactly was life? What exactly was death? Were they states? Or were they, as the newspaper would later say about Aldini's work, simply positions on a spectrum? Positions that could, perhaps, be reversed. Galvani himself was cautious about these conclusions. He was a devout Catholic and had no desire to challenge the theological understanding of death and the soul. His nephew had no such reservations. Galvani spent years on that balcony in every kind of weather, watching, recording, trying to understand what he had accidentally found. He never could have imagined what his nephew would do with the discovery. The Murder Act of 1752 in Britain had established something important for scientists like Aldini. It decreed that the bodies of executed murderers could be handed over to surgeons and anatomists for dissection rather than receiving a proper burial. This was intended as an additional punishment. The denial of burial was considered deeply shameful, but it had an unintended consequence. It gave anatomists legal access to fresh human bodies. George Forster had been hanged at 8 in the morning. By 9, his body was in a room at Newgate Prison, and Giovanni Aldini was connecting his battery. The accounts of what happened have been preserved in several sources, including contemporary newspaper reports and Aldini's own written record of the experiment. When Aldini applied the electrical conductors to Forster's face, the jaw muscles contracted. The face appeared to grimace. The left eye opened. When the conductors were moved to the ear and to the rectum, the body convulsed so violently that an assistant was thrown backward. When the conductors were applied to the hand, the fist clenched. One observer reported that the body appeared to breathe. Another said that at one point, the expression on Forster's face was so vivid, so apparently emotional, that several observers involuntarily stepped backward, convinced for a moment that the man was alive. Aldini was careful to record all of this in clinical terms. He noted which applications produced which responses. He measured the intensity of the contractions. He observed and he documented. But even he could not fully contain what the room was experiencing. Because what the observers were seeing was not just science. They were seeing a human face move. A human hand clench. A human body react. In a man who had been legally declared dead for 1 hour. The newspaper report published the following day in the Morning Post described the scene in terms that mixed scientific description with barely contained alarm. It noted that if Aldini had not known that galvanism alone could not restore life, an observer uninformed of his theory might have thought he was watching a resurrection. Aldini himself wrote that his goal was never to claim that the man was alive or being restored to life. His goal was to demonstrate that the electrical principle that animated living tissue did not immediately cease at the point of death, and that understanding this principle might eventually lead to medical applications. He specifically proposed that galvanism might be used to revive people who had drowned or suffocated, people whose hearts had stopped but whose bodies were still fresh. In this, he was not entirely wrong. The defibrillator, the device that delivers an electrical shock to restart a stopped heart, is a direct descendant of Galvani and Aldini's work. The science that Aldini was performing in Newgate Prison in 1803 was the earliest version of a medical technology that saves hundreds of thousands of lives every year. But none of that was visible in January 1803. What was visible was a dead man's face moving in a cold stone room while a crowd of scientists watched in silence. Giovanni Aldini's experiments sit at the beginning of a line that runs directly into the present day. The defibrillator, invented in the 1930s and refined through the 20th century, delivers an electrical shock to a stopped heart to restore normal rhythm. It has saved millions of lives. It is, conceptually, exactly what Aldini proposed, electricity applied to a stopped body to restart its function. Transcranial magnetic stimulation, a technique now used to treat severe depression and neurological conditions, applies controlled electromagnetic pulses to the brain. It works on the same principle Aldini was exploring when he applied his conductors to the heads of his subjects. The entire field of electrophysiology, the study of the electrical properties of biological cells and tissues, exists because Galvani noticed a frog's leg move and his nephew decided to find out exactly how far that movement could go. But Aldini's legacy is not only scientific. It is philosophical. It is the question he posed to everyone who watched his experiments and could not sleep afterward. If electricity can make a dead body move, what is life? Is it the electricity itself, the current running through the nerves and muscles, or is it something else, something that the electricity merely simulates? Modern neuroscience does not have a complete answer to that question. Consciousness remains deeply mysterious. We can map the electrical activity of the brain in extraordinary detail. We can stimulate regions of the brain and produce specific sensations, memories, and movements. We can maintain brain activity in a body after the heart has stopped, and heart activity after the brain has died. The boundary between living and dead that Aldini stood at the edge of in 1803 has not become clearer in 220 years. It has become more complex, more contested, more philosophically fraught. The question he was asking, at a table in Newgate Prison, in a room full of frightened scientists, with a battery and a dead man and the absolute conviction that understanding was worth any discomfort, is still being asked. We just ask it in different rooms now, with better equipment. But the question is the same. Where exactly does life end? And is the answer a fact of nature, or a decision we make?